Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a problem number 7 which is based on state space analysis. In this question we are going to obtain state transition matrix. So we'll see the question because we know the formula how to obtain state transition matrix. Question. Problem number 7. Obtain state transition matrix, that is STM. We can use a shortcut one also. For the state model in a state space where my A matrix is given 0, -3, 1 and -4. Now we have studied one formula how to obtain the state transition matrix. E to the power at is nothing but Laplace transform of Si minus A, the inverse. We'll use that formula to obtain the state transition matrix. First of all, we'll calculate Si minus A inverse and then we will apply Laplace inverse on that whole matrix. How to obtain state transition matrix? We will use this formula e to the power at equals Laplace inverse of Si minus A inverse. So first of all, we will calculate Si minus A. Then we will move on to inverse of it and then we will find out the Laplace inverse of that whole matrix. So how to achieve Si minus A matrix? So first of all, S is multiplied with identity matrix or you can say unity matrix. Then this whole A matrix is subtracted from Si minus A product matrix. Now, what is the actual equation for this matrix? The A matrix size is 2 cross 2, so of course we will use a 2 cross 2 matrix for unity matrix. And this whole product, we are going to subtract the A matrix from this whole product, and my A matrix is this. Now, just perform the multiplication. So S into 1 is S, but S into 0 is 0. So we'll write this is our product and this is our A matrix. Now we will perform subtraction. Now, how to perform subtraction? The first element is subtracted. This first element is subtracted from first. Second element is subtracted from second. Third element is subtracted from third. And fourth element is also subtracted from fourth. So we will do a subtraction. So S minus 0 is S. 0 minus of minus 3 is plus 3. 0 minus 1 is minus 1 and S minus of minus 4 is S plus 4, and this is nothing but our Si minus A matrix. Now what we are going to do, we are going to find out the inverse of it. Si minus A inverse is nothing but adjoint of Si minus A upon determinant of Si minus A. So first of all, we'll find out the determinant and then we'll move on to the adjoint of Si minus A. So first of all, what is the matrix of Si minus A? We have already calculated it. So this was the matrix. Now we'll find out first of all determinant. How to obtain determinant? We'll multiply these two elements and then the product of these two is subtracted from product of these two. So S into S plus 4 minus, we'll multiply these two values. Now S into S is S square. S into 4 is 4S, but minus 3 into minus is plus 3. So this is my determinant value of this Si minus A matrix. Now we will find out the adjoint. How to obtain adjoint of Si minus A? As I said earlier also, or in last numeric also, just exchange these two values and multiply minus sign with these two elements. Now we have exchanged these two values, so we'll write S plus 4 first and S on the last, and the minus sign is multiplied with these two elements, so minus into minus is plus, but this will be 3 will carry the minus sign. Now I'll substitute both my determinant matrix as well as adjoint matrix, but in Si minus A inverse formula. So first of all, adjoint I'm going to write in the numerator, and in denominator we'll write s square plus 4s plus 3. But we can write this denominator in multiplication, like 1 upon s square plus 4s plus 3, which is multiplied with this whole matrix. Now I'll multiply this element or this denominator part with each and every element of this matrix. So after multiplying denominator with each and every element of this part or matrix, you have got this equation. Now we will apply the formula, that is, we are going to find out a Laplace inverse of Si minus A inverse matrix, which means we are going to apply Laplace inverse of each and every element of this Si minus A inverse matrix. So according to formula, we are going to apply Laplace transform on this whole equation. So let's say all these elements I'm going to replace it by some different values. Let's say x1 of s, so if I apply Laplace inverse inside this bracket, then what will be the equation? I'll show you. Now I have applied Laplace inverse inside this bracket, so we can write Laplace inverse x1 of s with as well as x2 of s of Laplace inverse, and similar with next two element. Now Laplace inverse of x1 of s is represented by x1 of t. Next, Laplace inverse of x2 of s is nothing but. So similarly for next two element we can write. So here I'm going to substitute all the values of x1, x2 and x3 and x4 in this matrix. But first of all, we'll apply Laplace inverse on x1 of s, x2 of s, x3 of s and x4 of s one by one. So let's say this is my equation number 1. Now I'll compare this x1 of s, x2 of s, x3 of s and x4 of s value with the last matrix. So just look at here. What is my x1 of s? Where is my x1 of s? x1 of s is over here. So if I compare both this matrix, then I can say that my x1 of s is nothing but s plus 4 upon s square plus 4s plus 3. Similarly, my x2 of s is this, my x3 of s is this, and my x4 of s is this. So I will substitute all this value in my x1 of s, x2 of s, x3 of s and x4 of s term. So after comparing both this matrix, I have got x1 of s, x2 of s, x3 of s and x4 of s value. Now according to equation number 1, what we are going to find out? x1 of t, x2 of t, x3 of t and x4 of t. And how to achieve this equation in terms of t? By just applying Laplace inverse on all these elements. So first of all, we will apply Laplace inverse on x1, x2, x3 and x4, and then whatever outcome you will get in time domain, that value I am going to substitute in equation number 1. So first of all, we will apply Laplace inverse on all these 4 elements. So first of all, we will apply Laplace inverse on x1 of s, that is x1 of s value is s plus 4 upon s square plus 4s plus 3. So first of all, we will solve this equation but by using partial fraction method. So let's say my x1 of s is basically, now as I said, we will perform this Laplace inverse by using partial fraction method. So first of all, we will find out the factors of this denominator, and the factors are, look at here, the last term is always product of 2 digits, whereas mid term is always product of similar 2 digits. So if I said my last term is a product, or the product is obtained by 3 and 1, that is 3 into 1 is 3, and if I add same terms, then 3 plus 1 is 4. So my factors are s plus 1 and s plus 3, and according to these factors we can see that we can have, or we will write a 2 constant values. And let's say this is my equation number 2. Now what I'm going to do, I'm just going to multiply this left hand side denominator on right hand side. So automatically s plus 1 will get cancelled. My a is multiplied with s plus 3, and similarly s plus 3 will get cancelled. My b is multiplied with s plus 1, and this whole product is on right hand side, whereas my left hand side we have s plus 4. And this one is my equation number 3. Now just substitute s equals to some values so that you will get the constant values of a and b, or the answer of a and b. So if I substitute -1 in this equation, then what will happen? This s is replaced by -1. So -1 plus 4, answer is 3. Now look at here, if this s is replaced by -1, -1 plus 1 becomes 0, so whole b value will be removed. But look at here, if I replace this s by -1, then 3 minus 1 is 2, so we'll have 2a. So therefore my a value becomes 2 by 3. Now next one, I'll substitute or I'll replace s is by -3. If I replace s by -3, then what will happen? This s is replaced by -3. -3 plus 3 becomes 0. So whole a term will be replaced by 0. I'm not going to write that value. But look at here. If this s is replaced by -3, then -3 plus 4 is 1. But -3 plus 1 is -2. So we have -2 into b. And if I shift this -2 on left hand side, then I'll get -half. Now I'll substitute a and b value in my equation number 2, and then I'm going to apply Laplace inverse on x1 of s. I have substituted my a and b value in my equation number 2, so we have got this equation. Now I will apply Laplace inverse on both the sides. So if we apply inverse Laplace on x1 of s, then we can write it x1 of t. Now here 2 by 3 is a constant, so we'll write 2 by 3 as it is. Now what we have, 1 upon s plus 1. Here the 1 is a delayed or a shifted term, we can say. So in inverse Laplace transform, this whole delayed or advanced value is actually multiplied with the value of t, but with opposite sign. So here we have plus 1, so we'll multiply it by -1, so we'll get minus of t. Then this plus 1 is removed. Now what we have, only 1 by s, and Laplace inverse of 1 by s is, we know that it is nothing but a unit step. Now here also I'll take constant term outside, so -half plus answer is -half. Now 1 upon s plus 3, so inverse Laplace of 1 upon s plus 3 is, first of all this amount is added, or you can see this is the advanced value, so we'll multiply this t value by opposite value, a sign value of 3, and it is a -3. So we have e to the power -3t, then 1 by s is remaining, and inverse Laplace of 1 by s is nothing but u of t. Now we'll take u of t common, so what you will get? This is my x1 of t. Let's say my equation number, we have a p, because I'm going to substitute this x1 of t value in my equation number 1. Now similarly we'll find out Laplace inverse of x2 of s, x3 of s, and x4 of s one by one. Now we'll find out Laplace inverse of x2 of s. My x2 of s equation is this, -3 upon we have s square plus 4s plus 3. But basically in last part we have already calculated the factors of s square plus 4s plus 3, and which is s plus 1 and s plus 3. So we'll find out Laplace inverse, but by using partial fraction method. So we have a 2 factors, so we will use a 2 constants, and let's say my constants are a and b. Now just multiply this s plus 1, s plus 3 on right hand side. So what you will get? S plus 1, s plus 1 will get cancelled, a is multiplied with s plus 3. Similarly, this s plus 3, s plus 3 will get cancelled, b is multiplied with s plus 1. So we have equation. Now just simply substitute s values so that you will get the constant term values a and b. Now if I substitute s equals to -1, now the same term we are going to substitute in each and every part, that is in x2 of s, x3 of s, and x4 of s, because in denominator we have s plus 1 and s plus 3. Now all the s is replaced by -1, so -1 plus 1 becomes 0, so whole b value is removed. But -1 plus 3, answer is 2. So we have -3 on left hand side, and on right hand side we have 2a. Now if I shift this 2 on left hand side, what you will get? -3 by 2. Now we will find out next constant value, which is b. And so we'll substitute s equals to minus 3. If I substitute minus 3 over here, minus 3 plus 3 becomes 0. So whole a term is removed. And if I replace this s by minus 3, then minus 3 plus 1 is minus 2. So what we have on left hand side, we have minus 3, and on right hand side we have minus 2b. Minus 3 plus 1 is minus 2. Now I'll shift this minus 2 on left hand side. So what you will get? Minus sign will get cancelled. We will get only a 3 by 2. Now I'll substitute both this value in my equation number, let's say 4. Now I will apply inverse Laplace transform on both the sides. So look at here. Inverse Laplace of x2 of s is x2 of t. Now here from this equation I can take 3 by 2 common. Now what is remaining? Minus 1. So we will multiply minus sign over here. Now 1 upon s plus 1 we have already calculated, and it is, and the next one is 1 upon s plus 3. This one is also we have calculated in last part, that is e to the power minus 3t u of t. From here also you can take u of t common. And this is the equation of x2 of t. Now we'll find out the equation or the Laplace inverse of x3 of s now. Now my x3 of s value is again 1 upon s square plus 4s plus 3. So we have already factorized the denominator and they have placed over here. Now look at here. Here we have two factors. So we'll find out Laplace inverse by using partial fraction method. Now here we have two factors, which means we will use two constants. And let's say my constants are fixed and it is a and b. Now what we are going to do, you know that we will multiply this left hand side denominator on right hand side. So automatically you will have 1 on left hand side, and a is multiplied with s plus 3 because s plus 1 will get cancelled, and b is multiplied with s plus 1 because s plus 3 will get cancelled. Now as I said earlier also, my substitution remains fixed. So we'll first of all we'll substitute s equals to minus 1 in my this equation. So on left hand side we have 1 only, but if I substitute s equals to minus 1 over here, then minus 1 plus 1 becomes 0. So whole b term is removed. Now we will have only a term. So minus 1 plus 3, answer is 2. So we can write 2a over here. So my a value becomes half, or you can say 1 by 2. Now similarly we will substitute s equals to minus 3. If I substitute s equals to minus 3, then this minus 3 plus 3 becomes 0. So whole a term is removed. So on left hand side we have 1, but on right hand side what we have? Minus 3 plus 1 is minus 2. So we'll write minus 2b. And if I shift this minus 2b on left hand side, what you will get? b is equals to minus f. And I will substitute both this value in this equation. Let's say this is my equation number 5. So my x3 of s equation becomes now a is half and b is minus half. Now apply inverse Laplace transform on both the sides. So what will happen? x3 of s is represented by x3 of t. I'll take half of common because on both the numerator we have common term. Now, no need to discuss the inverse Laplace transform of s plus 1 and s plus 3 because we have s plus 1 and s plus 3 in last two part also, and the inverse of it is e to the power minus t u of t and e to the power minus 3t u of t. I'll take u of t common. And this is nothing but my x3 of t. Now we will find out x4 of t, but by using inverse Laplace transform, and then I'll substitute all this x1, x2, x3 value and x4 value in equation number 1. Now Look at here, my x4 of s equation is s upon s square plus 4s plus 3. We have already factorized this value, so we have s plus 1 and s plus 3, but we are going to obtain inverse Laplace using partial fraction. So we have a two factors, so of course we will use two constant, and let's say it is a and b. Now we'll do the same thing, we'll multiply left hand side denominator on right hand side. So what we will get, s is equals to, this a is multiplied with s plus 3 and b is multiplied with s plus 1. Because s plus 1 terms will get cancelled and s plus 3 terms will get cancelled when we multiply whole denominator with a and with b separately. Now, as I said, my substitution value of s is fixed, so we'll substitute first of all s equals to -1 in this equation. So this s is replaced by -1, so automatically this b value is removed because -1 plus 1 is 0. So what we have on left hand side, we have -1, but on right hand side -1 plus 3 is 2, so we'll write 2a. But if I shift this 2 on left hand side, what will get? My a value is -half. Similarly, we'll substitute -3. So on left hand side we will have -3, but -3 plus 3 becomes 0, so whole a term is replaced by 0. But -3 plus 1 is -2, so we'll write -2b. But if I shift this -2 on left hand side, what will get? Minus sign will cancel, so we have my 3 by 2 only. And now I'll substitute both this value in my equation number, let's say 6. Now we will apply Laplace inverse on both the sides. So x4 of s is nothing but my x4 of t. Now -half is a constant, and we know that 1 upon s plus 1 Laplace inverse is a to the power minus t u of t. Now I'll take 3 by 2 outside because it's a constant, and 1 upon s plus 3 Laplace inverse is e to the power minus 3t u of t. Now from this you can take u of t common. So what you will get, -half into e to the power minus t plus 3 by 2 e to the power minus 3t, and this is my equation number 4, or you can say this is the equation of x of 4t. Now I'll substitute all this value but in equation number 1. Now look at here, I have substituted my all x1t, x2 of t, x3 of t and x4 of t values in equation number 1. Now from this equation what we can say that in each and every term we have u of t. So if you want the u of t you can take common. So therefore my e to the power at equation becomes 2 by 3 e to the power minus t minus e to the power minus 3t by 2. Now here you can take 2 common in denominator as we have done in last 2 elements also. And this is nothing but the state transition matrix of given question. So this question is a little bit lengthy because we are going to find out, or we have to obtain the Laplace inverse of all the 4 elements that we have done right now. So this is how we are going to solve a straight transition matrix from using a matrix E. Similar question we are going to study in next video. So thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.